Welcome to AI TechBook. Today, how to fine-tune an open model on managed infrastructure without a GPU farm, and how to know when you actually should. For a long time, I avoided fine-tuning open models. I believed three things about it: that I'd need a whole cluster of GPUs, that it would cost a fortune, and that the point of it was to teach the model my company's facts. Every one of those turned out to be wrong. Managed infrastructure killed the cluster. Someone else runs the hardware now. A technique called LoRA killed the cost. And the third belief is the one that still trips almost everyone up. Fine-tuning changes how a model behaves. It does not change what it knows. Get that backwards, and you'll spend weeks trying to teach a model facts that it will happily forget. So before any of the how, you need the when, and there's a simple ladder for it. Here's the ladder I wish someone had handed me. There are 4 ways to customize a model, and they climb in cost and effort. Start at the bottom with prompting, free, instant. Next rung, retrieval, RAG, which pipes fresh facts into the prompt at the moment you ask. And here's the thing, roughly 80% of the time, when someone says they need fine-tuning, better retrieval is what actually solves it. Fine-tuning is the next rung up, and it earns its place for one kind of job: tone, a rigid output format, domain vocabulary, the shape of a tool call, or making a small model act like a big one. The top rung, distillation, squeezes a large model's behavior into a smaller, cheaper one. So the split is simple. RG for facts, fine-tuning for behavior. The best systems use both: retrieval for what's true today, fine-tuning for how the model should act. Which means the first question is never how do I fine-tune? It's, is this a behavior problem or a knowledge problem? Say it's genuinely behavior. Why is fine-tuning finally cheap enough to reach for? One idea changed everything, and it's smaller than you'd think. Full fine-tuning means updating every weight in the model. For a big model that's enormous, the compute, the memory, all of it. That's the cost everyone remembers. LoRA removes it. LoRA freezes the pre-trained weights. The whole model stays locked. And it injects a pair of small trainable matrices into each layer. You train only those little matrices on the order of 0.1% of the parameters. On a giant model, that's 10,000 times fewer trainable parameters than a full fine-tune and about 3 times less GPU memory. And here's the elegant part. Because that little adapter folds back into the model when you're done, there is no extra latency at inference. It runs exactly as fast as the original. You get most of the quality of a full fine-tune for a tiny fraction of the cost. Fine-tuning stopped being a rewrite the model project and became a clip on a small patch project. Small adapter, sure, but the frozen base model is still huge, and it still has to sit in memory. For a really large model, that alone won't fit on one GPU, so QLoRA shrinks the frozen part too. It compresses the frozen base down to 4 bits, using a format called normal float, and then trains the LoRA adapter on top of that compressed base. A couple of tricks keep the memory from spiking. Put it together and the result is the one that changed who could do this: a 65 billion parameter model fine-tuned on a single 48 gigabyte GPU, while keeping full 16-bit quality. One person, one GPU, not a cluster. The compute excuse is gone, which leaves the part that was never about compute in the first place. Here's the part I resisted longest, and it turned out to be the easiest of all. You don't provision the GPU. A managed platform does. And the workflow is basically the same everywhere. You prepare a dataset, usually a JSON lines file, just example prompts paired with the responses you want. You pick a base open model, something like Llama or Mistral. You launch a LoRA fine-tune. And the platform provisions the hardware, runs the training, and hands you back an adapter, no cluster to set up, no GPU to babysit. Hugging Face AutoTrain does it with no code at all. Predabase, Together, Modal, SageMaker. Each one removes the infrastructure a different way. The GPU farm you pictured, you were never going to have to own it, which leaves exactly one hard part, the one nobody can do for you. Managed infra and LoRA make the how almost trivial. They do nothing for the part that actually decides whether this works, your data, and whether you should be here at all. Fine-tune when 3 things are true. The task is stable with a known output shape. You can measure with a real evaluation that the base model has plateaued and isn't good enough. And you have on the order of a few hundred clean, consistent examples of the behavior you want. Quality beats quantity every single time. 1,000 carefully curated examples will beat 100,000 noisy ones. And there's a quiet payoff, because each fine-tune is just a small adapter. One base model can serve many of them. A different behavior for each task, all sharing the same hardware. Fine-tuning isn't a monument you build once. It's a set of small, cheap patches you keep. 4 things to carry out of this. 1. Fine-tuning changes behavior, not knowledge. Araj for facts, fine-tuning for how the model acts. 2. LoRA trains a tiny adapter on a frozen base, with no extra latency, and QLoRA shrinks the base so a huge model fits on one GPU. 3. Managed platforms run the whole thing from a single data file, no GPU farm. And 4. The real work is the data. The cluster and the cost are solved. What's left is judgment and clean data. Thanks for watching AI TechBook. If this helped, subscribe. Next up, serving many fine-tuned adapters from a single GPU.